Welcome to my channel TechneMoira. Today's episode is all about the restoration and repair of a Marantz cassette deck. So grab your favorite drink or snack, sit back and enjoy the show. So like the title of the video says, this is a double cassette deck of the brand Marantz, and the type number is SD-535. As far as I can remember, this was a model of cassette deck built end 80s, beginning 90s. Okay. And the layout, I would say, the look of the cassette deck is distinctly, I would say, end of the 80s. Yeah, definitely. It also sports the usual VFD display, okay, which is typical for that age. And as some of you by now will have noticed, it's not just one cassette deck, it's a double cassette deck, which would allow you, of course, to duplicate a cassette easily, you know, or who knows, I don't know if I could do that, but you could mix the cassettes, possibly, you know. But in my opinion, the advantage of this cassette deck is that one could easily replicate a cassette from one deck to the other. So unfortunately, the cassette deck hasn't been treated too nicely. There are a few flakes off of the paint and a few scratches on the bezel of the cassette deck, which is metallic, by the way, so this is not plastic but aluminum as far as I can tell. It's dirty, so yeah, it hasn't been treated too well, unfortunately. Now let's show you a view from the bottom, like there. So to open up the cassette deck, there are, as far as I can tell, 6 screws that I need to take care of, 2 on either side of the cassette deck and then 2 at the back. And the back, as usual for a cassette deck anyway, doesn't reveal too much. There you go. So the back of the cassette deck is nothing too special. It has kinch connectors for line in and line out. Okay. So you have out left and right and in left and right. Okay. Out obviously towards the amplifier of your hi-fi installation. In, of course, for any source you'd elect to record from. I mean, it could have been a tuner or a record player or whatever you could select in your hi-fi installation. It does have, though, this, which is called remote control in and out. Strangely enough, it's 2 kinch connectors, nothing more. Honestly, for the moment, right now, I can't say what type of signal this would accept. Is it an analog signal or is it a digital signal? I'm guessing it's probably a digital signal, and the fact that it has an in and an out means that it could probably be daisy chained with other Marantz equipment. So at the back of the cassette deck there's not too much to be gleaned, except of course that as all cassette decks of that age, it has built-in Dolby noise reduction, as you can see right here, and HX Pro noise reduction produced by Bang & Olufsen. Some of you might remember that, generally speaking, the sound quality of a cassette recording wasn't always that good. So to improve the sound in the late 80s and the 90s, they made heavy use of filters like Dolby and HX Pro. So then there is the brand. So it's a Marantz model number 74S SD-535/O2B. But when you go look it up on the internet, generally it is advertised as an SD-535. Okay, Phillips head screw, not very long screw, about I would say 8 mil, maybe 10 millimeters long. I took the executive decision that I would unmount the main board you see in front of you and the front panel where the two cassette deck mechanisms are mounted to, out of the metal case in which both are mounted. Now to do that, it's a little bit complicated, but basically what it will amount to is to unscrewing a few screws. So on this side of the main board, right here and right there, there are the screws that I need to unscrew first. So that screw here and this screw over here. Alright, and then I need to carefully, gently lift the main board over these plastic standoffs. Yeah, there's one here and then there's one right down there. Okay, so that's the thing that in the end I will need to do. But there is something which complicates the matter, and that is the transformer. So logically speaking, you would say, oh, you know, all you need to do is to unscrew the transformer, which is held down by 4 screws from the top, right? So there are 2 screws here and there are 2 screws there. But actually, after taking a closer look at the bottom of the cassette deck, which is a bit heavy, hang on. So if you take a closer look at the bottom of the cassette deck, the thing you notice is these two little screws here. So there's one there and there's one there. And you notice that there's a cutout in the bottom of the cassette deck that would be reached by these little tabs you see there. And that seems to suggest that rather than unscrewing the transformer from the top, you need to unscrew these little screws and then rotate the whole main board by, I'd say, roughly 10 degrees to lift it out. Once you've unscrewed it, of course, from the top. Now, to release the front panel, I will have to unscrew 3 screws. So one here, one there, and one over there. And I think I will have to unscrew these 2 screws as well here, but from the other side, right? So yeah, 5 screws in all. Now, what about those plastic tabs that hold the main board to the case of the cassette deck? You can release them from the bottom, right, with some duckbill pliers. And in the end, I think that is exactly what I will do. I will undo them from the bottom. So there's one tab here and there's one over there, and all in all, that seems to be the sensible thing to do. So okay, what I need to do first is to unscrew those 2 screws at the top. So one in the corner over there and then one over here. And once I've done that, most of the things I need to do are all from the bottom, except of course unscrewing those screws from the front panel, right? So there's one down there and there's one over there. Alright, so next tip I can give you is to release the front panel, you will also have to release 2 screws on the top here. So one at the total right of the front panel and one at the outer left. Yeah, only these 2 screws, and that will allow you to unmount the whole front panel, right? You can see that I can move the whole front panel. Now, I'm not going to do that just yet. What I want to do is to release the main board, yeah, the plastic tabs that are holding the main board in, right? So there's one plastic tab. I don't know if you guys can see it, probably not. Let me show you. So there's one plastic tab right here, and there's another behind this wide ribbon cable. Let me show you. And it's hiding over there. Over there. Yeah, there. And the trick to do that is like this. I hope I can show you. So you need duckbill pliers, okay? So duckbill pliers have a gripper which is completely flat. Yeah, there's no knurling in the gripper, so it will do minimal damage if you grab a component with this. Okay, so the duckbill plier, and what I need to do next is release that little plastic thingy over there with these pliers, and I do that by doing it like this. I hold it on the inside with my left hand and I grip it with the pliers about halfway, squeezing them together, and then I should be able to, yeah, push them through like that. Okay? So I did that with both plastic tabs. Yeah. So when I shake the main board, you can see the move, right? Yeah. Okay, so now comes the crucial point. I need to rotate. I need to rotate the whole main board, which is sitting like this, about 10 degrees down counterclockwise. Okay? But I have to be really careful because now it's totally unscrewed and everything, so it might go quickly now. Alright, I unscrewed 5 screws and well, that released the back plate, okay, of the Marantz. So now I should be able to unmount the front, which indeed I can, yeah, and I should be able to rotate the whole main board about 10 degrees to release it, yeah. Let me see. Yeah, pretty close. Pretty close. And indeed it's loose, but it's still a bit stiff. Let me see. Okay, maybe I need to slide it forward. Ah, like that. Okay. There you go. Et voila. Our first look on the main board outside of its case, right? Isn't that cute? Now it's a huge board actually. I mean, huge for a cassette deck. But let's not forget that the Marantz cassette deck was a piece of high-end equipment, right? So people back in the day would have paid a real heavy price to own it. I don't know how much it costs, but I'll look it up and I'll put the price up on the screen about here so that you can judge for yourselves, right? So yeah, it's quite an intricate machine, you know. Now at first glance I can't see anything wrong with it. What I do notice is that there are an enormous amount of electrolytics, and okay, this is the bottom part of the main board. Yeah, and it's a beautiful PCB, really. So I mean, yeah, the engineers at Marantz did a great job, although in my opinion this is probably a mainboard that was designed by the Sony company, not so much by Marantz engineers themselves, because, or possibly even, you know, Matsushita or something, because quite a few parts are Sony parts in here. So you know, my suspicion is that it was at least co-designed with engineers, Sony's engineers, right? It just looks so very clean and well made, you know. Um, a good Sony product, I would almost say, yeah, but which has been branded Marantz. Okay, so what I'm going to do next is I'm going to disconnect all the connectors from the main board so that I can put it aside for the moment, and that way I can work freely on the cassette deck mechanisms, because they will more than likely need some good cleaning and possibly even new belts. Okay, so to be able to do that, I'm going to take pictures of each and every connector. Yeah, and once that is done, I will disconnect them all, and then I'll give you a closer look of the front panel with the cassette deck mechanisms. And there you go. I unmounted the bezel of the front panel, and I'm not sure if it's aluminum or aluminium, but it might be because it's fairly light. Anodized, probably, I would say, yeah, anodized, not painted, but anodized black. Black and gold, actually, which are the colors I seem to remember Marantz like to use, preferably, you know, black and gold. So yeah, this will allow me to clean the front bezel separately, and to repair a few nicks and gouges in it, you know, scratches. So hopefully it's not too bad, that I can repair it somewhat. But yeah, isn't it beautiful? And you can release it separately by pushing in just a few plastic tabs and lifting this gently off the front panel, right? There are two plastic tabs at the bottom right here you need to push in, yeah, and there are three plastic tabs at the top that you need to, if I'm not mistaken, I needed to, yeah, push them in as well. Yeah, push them in, yeah. So you have one here, one in the middle, and one at the right. Et voila! One mechanism removed from the front panel of the Marantz, right? It took a bit of searching to find out how to release it, but in the end it wasn't too complicated. It was 4 screws, I think, 4 or 5, let's see, 4. It took me 4 screws to release the left mechanism, and unclipping a little wire from the back, which is quite a bit of a nasty little detail. Let me show you. So, apparently this wire bundle, so this white and red wire, these red and white wires were attached to the mechanism at the back with a little zip tie, and in fact it was they were attached to, I think, a little eyelet somewhere. Let me think. They were attached to, I think it was this eyelet here, this one here, with a little zip tie. And had I not noticed it in time, I would have ripped them out, you know, and that would have been, yeah, that would have been a small catastrophe. So yeah, you need to unclip or cut through the little zip tie and then undo these little wires here. But once you've done that and removed the proper screws, which are, well, like I said just a few minutes ago, 4 in all, well, there you go. Then the prize will lie in your hands, you know. Here it is. The Cassettedeck mechanism, right? Well, at least the left Cassettedeck mechanism. So it's really dirty, and it will need quite a bit of cleaning. So I'm really happy it's unmounted, because at least now I can start looking for problems, if there are any, and clean it out and maybe even replace a few worn parts, right? I'm taking general stock of the situation of the left side cassette mechanism, I should say cassette player mechanism, just to find out what it is that I need to do, right? So I'm looking for obvious faults in the mechanism, like, you know, broken belts, broken gears and stuff like that, and so far there's nothing really obvious sticking out. But there is one thing that I did notice, that is that if you look at the solder points that lead to the motor, yeah, and you look at it from close by, let me show you. Do you see anything that looks suspicious? No? Well, look at the surface of those large round solder points. Do you see all those tiny little dimples and scratches? So something tells me that somebody has been in here before me, obviously, and has made a few measurements on those points with exactly, let me show you, with exactly this kind of measurement probe, you see, very fine tipped measurement probe. It's almost needle-like, you know, very sharp. Yeah. So somebody was in there before me to make some measurements around the motor, which seems to indicate that there might perhaps be a problem with the motor. So you might wonder how to quickly, cleanly release these tensioning wheels, right? And nothing could be simpler. You just use a flat-headed screwdriver like this, alright, and you shove it gently, of course, underneath the wheel, right under the wheel. You shove it in, and then you hold your fingers on top of the wheel so that it doesn't fly off, and then you lever the screwdriver down like this, and there you go. That's how you release the tensioning wheel. Okay, now be careful, the axle of the wheel is quite loose, so if you don't keep hold of it, it will fly off, as has happened to me a few times. Yeah, and it's like a little metal axle like this, you see. So yeah, if you're not careful, this axle will go fly off somewhere, and good luck finding it back, right? You'll notice that the motor has a double function, and therefore has a double pulley, right? Now, although it may not seem like it, seen from this angle, there is actually space underneath the pulley. So if you look away from the motor downwards, there is actually space between the end of the pulley and the chassis below, right? That couple of pins you see there are really helper pins. You know, they help putting on the belt later on onto the pulley, right? So they serve no other function than that. But they're not standing in the way, so with a little bit of navigating you can actually squeeze the belt from in between those two pins and the pulley and out, you know. So yeah, I'm not saying it's simple, but it is doable. Yeah, it is feasible. Now if you look at it, at the one belt from the top, you know, one of the function belts, you could say, then you see it there on one of the wheels, right? So let me show you. There it is. Okay, on that wheel. And if you look between the PCB and the wheel, you can see there's just enough space to squeeze a belt through, to lift it off the pulley, and then to squeeze it between the pulley and the PCB, and then take it out from this opening here. Yeah. So, and we're talking about the square belt right down there, okay, that one, at my fingertip, yeah, that one I'm lifting right there, yeah. So, it is feasible, yeah, it can be done, but you will need some patience, yeah, and I would say at least a few toothpicks and a pair of tweezers, okay, to do it. Alright, I'm going to try to give you guys a look at how I fish out the little drive belt from out of the mechanism, right? But due to the small amount of space I have, it might be that I will obstruct the view sometimes for you guys, but either way, I'm going to use a pair of metal tweezers, you know, stainless steel tweezers, and a pair of wooden skewers, okay, but toothpicks would probably work just as well, okay. So the thing is that I need to fish that little belt away from the pulley on which it rests now. Then I have to use the skewers or the wooden sticks to lever the belt over the wheel so that I can remove it, right? So, and I'm not talking about placing it back. That will be another pair. That will be another problem, you know. So, either way, so there you go. I grab the so I grab the belt with my tweezers like this. Yeah. I take one of my skewers and I place it under the rubber belt like this. I don't know if you guys can see this, but I'll see if I can give you a close-up. So there. I think, yeah, I think you can just about see the belt resting on the tip of the skewer, right? So right there, okay? So now I need to lift the belt away from the pulley with the second skewer. So I slide it underneath the belt and then I push the skewer with the belt over the pulley's top. Yeah? Obviously, and that's kind of hard to show you, but yeah, and I grab hold of it all the time with the other skewer, right? So, before I can release the belts, unfortunately, I noticed that there's one more obstacle that we need to overcome. And I hadn't noticed it at first, but it's that plastic pillar you see down there where both rubber belts are snagged, you know. I don't know if you guys can see that, but there's a rubber pillar there, yeah, which is holding the rubber belts back. So unfortunately I have to unmount the motor, and the only way to do that is to release two little screws which are buried down there, you know. There are these two round openings you see here, and inside there are two, well, inside each hole there's one Phillips screw. Yeah, I don't know if I can show you guys, but you see it down there? Right? That's one of them. I removed the other already. So, and they are mounted pretty deep inside. Yeah? So you will need a screwdriver with a long neck, you know. Now this is, well, this is overdoing it a bit, but I mean it's the only one I have with a long shaft, right? And you will need a head like this. Okay, this is the kind of head you will need to unscrew the screw, right? So give me a moment to unscrew the other screw, and then I'll show you what happens when I lift the motor. There you go. That's the outer screw. Okay. See? That's one of the screws that needed unscrewing. So off it goes. So now the motor is loose, and there you go. Yeah, you can just lift away the motor from the mechanism, and that releases both belts. So there you go. And now that I have the belts in my hand, they feel a bit stiff. You know, they're not so supple anymore. So I think maybe I should replace them in the end. But yeah, there you go. They are still serviceable, but I think I will replace them in the end. And that's the space underneath the motor, okay? And the motor itself with the little pulley, right? Alright, I unmounted the motor from the cassette module over there, right, which required unsoldering 4 little wires. You see them there. Alright, and you see the left wire, the left of the 4 is coated with a white stripe, right? Just remember that detail for a minute. So when you unsolder the motor, at the top of the motor are mentioned these symbols. You see on the left a minus, then a plus, then a B and an A, right? Okay, so those contacts are really nothing more than the minus and the plus is the power for the motor, and the A and B contacts are the signals that represent, as it were, the speed of the motor, right? So there's a sensor in that motor which tells the cassette deck at which speed the motor is running, right? Okay, so when you unsolder the motor and you connect up the motor to a power source, which in my case is my lab power supply over there, alright, you can set it to say, or to be safe, to start with to a fourth of the power that the motor is rated for. And if you wonder what the motor is rated for, it's written on the label of the motor. Yeah, I don't know if I can show you guys, but at least not easily, not with all these probes on, but there. You see, it's rated for 12 volt DC and for speeds between 2000 and 4000 RPM. Now, when you look for a new motor, all these specifications are important, including the CCW you see in the right hand lower corner, right? The CCW means counterclockwise, and that's quite important because you can buy several versions of this motor, right? And some of them are rated for only 2000 RPM, and some are rated for only CW, so clockwise. So it's really, really important that you look for a motor with these exact specifications, okay? Now, one more detail. On the internet you'll find a bevy of these motors, but instead of YD at the end of the type code, you will find AD, okay? And the AD motors have nearly exactly the same specifications as this motor, except that they are only rated to run to maximum, let's say, 2400 RPM, not 4000 like this one. Okay, so it's really, really important, if you need to replace this motor, to look for the exact same specifications. Yeah, I mean, other than obviously the size of it and the attachment points and etc, etc. Okay, so you will probably find replacement motors for this one, but without, of course, this little pulley you see here on top, right? So you will have to unmount this pulley from the broken motor and transfer it to the new one. Alright, so now imagine that you don't have all the equipment that I have, but you still want to find out whether the motor works or not. Well, we've just seen that this motor is rated for 12 volts DC. So if you connect up a power source to these pins here, so the minus and the plus, then you can test in fact the motor, right? And when I say power source, it can be anywhere between, say, 3 volts DC and 12 volts DC. Okay, so and no need to go overboard. I mean, you don't have to put immediately the full 12 volts DC on the motor, right? Let's say 3 volts to start with is more than enough. So that's what I did. I attached the motor to my power supply, and I'm going to switch it on right now. Okay, my power supply is set to 3.2 volts DC, and the motor right now is consuming about 10 milliamps. Okay, could be a little bit more, but not much more than that. And in fact, when you look at the axle of the motor, I think you can just about see it rotate. It's kind of difficult to see, of course, since it's all black, but I think you can see it rotating, right? Now, this only says the motor is running, but it doesn't say whether the motor is still good or not. Now, when you touch the axle, yeah, the pulley as it were, you should feel quite a bit of resistance from the motor. Alright, now at 3 volts you won't feel a lot of resistance, but at 12 volts the motor should be able to resist any friction rather well, you know. So in other words, it has to output quite a bit of torque to run properly. Yeah. So it's a very crude method to find out whether the motor still works or not, but at least you could do it even without a power supply. If you have, say, a 9-volt battery, or even a few AA batteries, 1.5-volt batteries or such, you can still test the motor, you know, with just a few batteries. Remember not to exceed 12 volts, right? So if you're going to go over 12 volts, you are definitely going to damage or burn the motor. Now, some of you might have spotted that I also have a few probes, or well, at least one probe, attached to the AB outputs you see there, right? Now, those outputs allow me to check the speed of the motor. Yeah. In fact, it outputs a sine wave according to the speed it's running at, right? So right now it runs with 3.2 volts DC, and you can tell by looking at the screen, at the bottom of the screen. Let me show you. Yeah, sometimes it says frequency not found, but it's really not a very clean frequency, but it's somewhere in the ballpark of 70 or 80 hertz. Yeah, it can jump up a little or go down or somewhat, but yeah, it's, let's say it's low frequency. Alright, now if I augment the voltage on the motor, that frequency should start to go up. So let's go to 6 volts. Okay, let's go to 6 volts. There you go. 6 volts. Okay. Let me feel. Oh yeah, it's definitely running faster. Okay, so let's look for the signal. So there you go. Okay. So I pushed the frequency, well, the speed of the motor up to well, the voltage of the motor, or the DC voltage, is 6 volts right now. And as you can tell, if you look at the frequency measurement at the AB output, yeah, the frequency has gone up. It's not very stable, but yeah, it's somewhere in the, I would say, the 250 Hertz ballpark. Okay. Well, as you can tell from the screen, the signal is really not very clean. Yeah. And there you go. That stabilized it somewhat. So yeah, it's around the 250 Hertz. So obviously, the more power I'm going to feed the motor, the higher that frequency will become. Alright, and there you go. The soldered contacts. And they are clean and solid. I tested them by pulling a little bit on the wires, and everything is solid. And there's no crosstalk. So no short between the contacts. I measured it with my multimeter, right? And with ultra fine probes like these. Alright. So there you go. That's done. On with the cleaning and replacing of the belts, and then the greasing of the mechanism. Alright, so the whole mechanism has been cleaned, top side, bottom, left and right. I used a combination of alcohol, methylic alcohol, at 95%, I think, and I also used some WD-40 to degrease some of the old grease that was still visible and present on the mechanism. But now, of course, the whole thing is degreased. So I need to re-grease the gears and the sliding parts. And I thought for this year I'm going to try a new type of grease. Well, I mean a new brand of grease. But it's still white grease. You know, like this. Okay. They call it white grease because I think it's on the basis of lithium. So lithium grease, really. And it's a spray instead of a paste. So I think this might work a little bit better on the moving parts of a Cassettedeck mechanism, right? So what I'm going to do is I'm going to spray mainly inside the mechanism, and there are some gears. I think you can, let me show you. So there are gears inside the mechanism down there. I think you can just about see them. Okay. and those gears need a little bit of greasing, okay? So, and when I say a little bit, I really mean just a touch, you know? You don't need to go overboard. Also, when I zoom out a little, there are these sliding parts here, you know, like this part here, and there's the rotating part, like the rotating reader head right here, and all of those parts, they will also need, let's say, a touch of grease, you know. So what I'm going to do is I'm going to spray from the front and the back some grease, um, protecting the parts that don't need grease, so mainly the head. So let me show you. So I'm going to protect the head and the capstan rollers there, you know, with a little bit of paper or cardboard, such that the spray doesn't land on them. Okay, so I wedged a piece of paper over the parts that I don't want grease to land on. So now I'm going to take my spray can and at an oblique angle spray some grease into the mechanism, right? There you go. Okay. All right. So lithium grease is supposed, or white grease as they say, is supposed to be more lasting, you know. So in the sense that when you put some white grease on a part, it's not supposed to disappear so quickly, and yeah, it lasts a lot longer. Yeah. So that's exactly what I intend to do, making the grease last a lot longer, you know, especially on the moving parts, right? And you can tell from the paper that I really needed to protect the parts below, right? Because the spray head on the can is rather indiscriminate, yeah. So that is not something that you want. I'm using an earbud, well, an ear cotton swab really, to clean off the excess grease, you know. Because yeah, there's always excess grease possible left and right. So like that. Okay. So yeah, there you go. So all the moving parts are going to get a slight spray of lithium grease, you know, just to make sure that they move correctly, right? So um, um, there you go. Oh damn. I did land some grease on one of the rollers, just a spatter, but yeah, I need to clean that off. I won't lie, it took me the better part of an hour to get the belts mounted. Also, I had to look for another small belt, because one I used previously, one of those down there, was just a little bit too large, and the one I found, the replacement belt I found, was just a little bit smaller, by almost a centimeter smaller. So it's about 6.5 centimeters on one side, or in other words 13 centimeters full length, and that's apparently the ideal length. Okay, and it's a square profile, obviously. Alright, so there you go. One thing that I forgot to mention, that is that when you're going to mount everything back, okay, just make sure that you have the screws to mount the motor back close at hand, so, and the right screwdriver. Okay, you need a reasonably long screwdriver with a small Phillips crosshatch head, yeah, to reach the motor with the screw, right? So yeah, there you go. Oh, and by the way, yeah, I had made a small mistake at first. So I wanted to mount the small drive belt first, but obviously you need to mount the large one first and then only the small one. Okay, so really it's what do they say, last out first in, yeah, lo-fi. Okay, so there you go, the belts are mounted finally. It's really not one of my favorite jobs, you know, restoring, when I'm restoring stuff. I mean, it's on par with threading radio dials, you know, when the needle, the needle that moves, or the wire that moves the needle on a radio dial, well, when that breaks, well, that's also a hellish job to repair, you know. Alright, I am yet again thwarted by circumstances. I had ordered a new motor for this cassette deck mechanism, and it's clean, but unfortunately I can't mount the new belts without a motor, right? And by the way, I also ordered a set of new rollers, pinch rollers or capstan rollers, for inserting them in here, right? Because the old rollers are simply just too hard. They lost their rubberiness, their pliability, yeah. And yeah, I ordered a set of new rollers, and together with the motor they still have to arrive at my place. So until I get them, there's not a thing I can do, right? So I'm going to stop the episode, this episode, for now, and then we'll continue next episode with well, the finishing of the Marantz cassette deck, right? So anyway, thanks very much for watching, and I'll see you all back for the next episode with pleasure. Thanks a lot, and until then, bye.